What's up? What's up? What's up? It's your boy, the network. And today's topic is Section 3.23, Configure and Verify Eigrp for IPv6. This is a topic in the CCNP ROUTE exam code 300-101 version 2.0. They just updated the new CCNA exam. They got new versions of the CCNP exam. So make sure you are studying. I believe the new ones are coming out on February 23rd. 2020. Right now it is June 12th, 2019. So remember those dates so that way you know if you catch this, you stumbled upon this video, you know which version this exam was for. Let's go ahead and take a look at the exam blueprint, see where we came from, where we are headed. All right, again, this is the CCNP ROUTE exam, implementing Cisco IP routing. That's the exam code. Again, it's exam code 300-101 version 2.0. I don't know the new codes yet. I haven't really looked. I just saw it all on my Twitter feed. Everybody was talking about it. I don't think I'm gonna do a video on that. If you want to know about the new exams, I'll probably put a link in the description below because I gotta try to knock this stuff out because I have yet to take this exam as well. And the new one is coming out February 23rd, 2020. Notice how I've got that date memorized. We just wrapped up the video for describing and optimizing Eigrp metrics. Again, today we are going to configure and verify Eigrp for IPv6, which is basically the IPv6 version of Eigrp, a routing protocol. After that, we are going to finally move on to OSPF and starting out by describing the OSPF packet type. So, you know what IPv6 is, right? It's the new version of IPv4, the newer version, I guess if you want to say. Eigrp is a routing protocol. It is a Cisco implemented product, basically a Cisco routing protocol, but it's now open source, so you can use it on Juniper devices. You can use it on, I don't know, Riverbed, any other kind of routers that supports Eigrp. Let's go ahead and look over some facts here. So again, this video is going to be, we're going to be discussing Eigrp and IPv version 6. These are two Wikipedia definitions that, you know, basically describes each of these two concepts that we're combining together. We are going to configure them using Boson NetSim, that's right. And then we are also going to verify them by running a couple show commands. Eigrp is an advanced disinvector routing protocol. I'm not going to read all this to y'all. We already discussed what Eigrp is in the past couple videos. I might have to race through these videos because, again, new version is coming out, so we need to get through this. IPv4 or IPv6 is the new version of IPv4. See, as you can see right there, last sentence, IPv6 is intended to replace IPv4. I know y'all waiting. Let's just jump right into it, right? We need to discuss some of the theory first before we jump into the configuration here. Here's the commonalities with IPv4. Uses layer 3 protocol type of 88. You remember when you pull up the IP header? This guy right here. This is the IP header right here, right? Well, the protocol type, once you see it says 88, that's how you know it is a packet that is for Eigrp IPv6 type header. So if you see an 88 here in the protocol, if you're running Wireshark or any other kind of protocol analyzer that says 88, then you know this is IPv version 6, they also call it. It also uses successor and feasible successor log, just like IPv version 4. It uses the dual, which is diffusing update algorithm, basically the formula it uses to calculate routes using Eigrp, the best routes. It uses triggered updates, meaning it once something happens, then it gives you an update. So it doesn't give you period as opposed to periodic updates, such as like 30 seconds, like RIP gives you updates every 30 seconds. Eigrp waits till something happens, like a link goes down, that's a trigger, then it gives you an update. That's what a triggered update is. It uses composite metric, default using bandwidth and delay. We discussed that in the last video, right? There's 5K values, 2 of them are default, K1 and K3. Those are set to 1, which are bandwidth and delay. And the metric of 2 to the 32nd power minus 1 equals infinity. We talked about this, I believe, in the route poisoning video. This is basically any infinite metric means it's unreachable. That's what that is. So the same thing as IPv4. That's what IPv6, Eigrp IPv version 6 does. That's the IP header. We discussed that. Differences, but the differences between the two. It uses the neighbor's link local address as the next hop IP address. So if he needs to know the next hop IP, it uses the link local address of the next hop. Eigrp for IPv6 does not do auto summarization due to no classical networks. Neighbors are not required to be in the same subnet, so it's a little easier to configure, as you can see. We'll go through the configuration here in a bit. And FF02::A, this is a compressed address. Remember, there's a bunch of zeros that's going to be in here. There are separated by not octets. I don't know what they're called, but there's 8 sections in an IPv6 address. I'll put a comment below to let y'all know what that is. I can't remember off the top of my head. It is used as the multicast update address. Here are the verification commands. It's similar to IPv4 version of verification commands for Eigrp. You just replace the IP with IPv6. So example, you do show IPv6 route instead of show IP route when you do a version 4, IPv version 4, right? Same thing with the rest of these guys. Show IPv6 protocols, etc., etc., etc. We'll go through it when we do the configuration. Let's go ahead and launch up Boson NetSim and run this lab at the bottom. Actually, we're not going to run this lab configuration for IPv version 6. I believe that's the easier version. This was more for ICND 2, which also by the way, they're getting rid of the CCENT exam or CCENT certification. So right now it's just CCNA. That's it. I believe you can take 2 exams still. I'm not too sure. But yeah, they shook up the whole world with in Cisco Live with these exams. Anyway, let's go ahead and launch that up. Okay, so here goes our topology. Now I know it looks a little scary. It looks like this is just like an enterprise network. But we are going to work with these 5 routers here in the middle, I believe. Yeah, 1, 2, 3, 4, 5. That's going to be called Site 1, right? Don't worry about the rest of these guys. This host, this ISP. The rest of these guys is private, all these other guys. We're just going to worry about these 5 routers right here. This is Site 1. That's what we're going to be working with. Let's go ahead and read the objective here. Configure Eigrp for IPv6 for the core. This is called the core, Site 1, right? Of a mixed IPv4 and IPv6 environment. Verify connectivity, which we're going to be doing with running a bunch of show commands. Between all IPv6 capable devices within the core network. Use show commands to verify them. You will only be working with devices in Site 1 in this lab. Again, Site 1 is these 5 routers right here. As you can see right there. Site 1. That is the subnet right there. 100 to 50 50/56. Let's go ahead and jump right into it. In this task, we are going to configure Eigrp version 6 to share routing information between the routers of Site 1. Again, let's jump right into it. We're going to do AS 600 for these guys. Eigrp requires the equivalent of an IPv4 address as a router ID. So when we're doing a router ID, we're doing an IPv4 address. So 4 octets. It's going to look like an IPv4 address. So you can uniquely identify a router within an AS. What are the selection criteria a router uses to generate an IPv6 router ID if one is not manually configured? Just like IPv4. You choose the highest active loopback address, and then if that's not available, you choose the highest IPv4 address. If that's not available, then you just can't. It's just not going to have a router ID. Before you configure an Eigrp routing process on router 1, what features should you ensure is enabled on router 1? Well, that's easy. Unicast routing. And I'll show y'all what happens if you don't do that. Enable. And then let's say you wanted to turn on the Eigrp, right? You do configure terminal, and then do IPv6 Eigrp, router Eigrp, and then it's going to be 600. And this is what happens. IPv6 unicast routing is not enabled. So essentially, you got to run that command to turn on IPv6. It's not enabled by default. So we're going to go ahead and do that. IPv6 unicast routing. Now IPv6 is turned on, right? On router 1, create an Eigrp routing process, and that's what we tried, that uses AS600 and ensure that the routing process is enabled. We enabled it. Now let's go ahead and do that routing process. We're going to run the same command right there. Now it's on. So now it took it that time, right? On router 1, display information about the running IPv6 routing protocols. Did router 1 automatically generate a router ID for the routing process? If so, what did it use as its router ID? Let's see. We're going to get out of this and do show, not IP protocols, because that's for version 4. We're going to do show IPv6 protocols. And there it is, right? We've got Eigrp 600. We also generated a router ID, and that's the answer right there, 10.10.10.2. right? 10.10.10.2. Next question, on router 1, identify all interfaces that connect to the routers within site 1, then enable EIGRP on those interfaces. So on router 1, right here, we need to identify all the routers that connect to routers within site 1. The site 1 is all these guys, right? So we got an interface here and an interface there, right? What interfaces are those? We got router 2 and router 5 connected to those guys. Those are the local interfaces, FA00 and FA10, right? That's where we need to enable EIGRP version 6. So we're going to go to global config mode, interface FA00, my bad, 0, and then we're going to do IPv6 EIGRP 600, and that's how you enable it, right? We're going to do the same thing on the next interface, which is interface FA0/1, IPv6 EIGRP 600, and now we've enabled it. So how do we verify that? That's what it says here. Next question says, on router 1, display information about EIGRP interfaces. Verify that all interfaces on router 1 that connect to routers within site 1 has been configured. And we do that by doing the same command that we just did before. Remember, not show IP protocols, because that's for IPv4. We're going to do show IPv6 protocols. And there's our router ID, right? Default K values, right? K1, K3 are set to 1, the rest is 0. Again, it's 600. There's our router ID. And so far, we only have one interface that has EIGRP version 6. What happened to the other one? Why did we not do that? Invalid command, that's why. FA01 was not the command we wanted it to do. We want to do FA10, so it's a good thing we ran our show command. Let's go ahead and fix that problem. Configure terminal interface FA10, right? And then IPv6 EIGRP 600. Now it's enabled. Let's run that show command again. Not show IP protocols, right? We're doing show because that's IPv4, IPv6 protocols. And now we have two interfaces that are in EIGRP version 6, right? Okay. Ensure that unicast on router 2. We do the same thing on router 2. So that was router 1. Now we're going to go to router 2 and do the same thing. We're going to ensure EIGRP IPv6 unicast routing is enabled. Create an EIGRP routing process that uses AS600 and enable EIGRP on interfaces that connect to routers within site 1. So basically, same thing we did on router 1. Let's ensure unicast routing is enabled. I'm going to go to enable, global config mode, and then IPv6 unicast routing. That turns on IPv6, right? Now we need to create an EIGRP routing process that uses AS600. So we do IPv6 router, EIGRP 600, and then what else they wanted us to do? And identify the the interfaces that connect to the routers within site 1. So router 2. We have this interface and that interface. We don't have to worry about that one because this is not within site 1, right? So we got to do this one and that one. That's router 1 and router 3. What's connected to that? We have router 1, router 3, FA01 and FA00. How else could we have done that without looking at this? Because you're not going to, in the real world, you're not going to have this nice, clean topology. Basically, we might have to do like show CDP neighbors we could do. We could also do, that's probably the best command we could run. We may have to do a little bit of homework. But for now, for the sake of this video, and for the sake of the new exam coming out on February 23rd, notice how I'm talking a mile a minute. We need to get through this. So FA01, we need to do that with. So interface FA01 and turn on IPv6 there. Yeah, GRP rather. Version 6, and then EIGRP 600. So that basically we're saying that interface is going to participate in EIGRP 600, AS600, and then the other one was, what was it again? We did FA01. Now we need to do we did that one. Now we need to do this one, FA00. So interface FA0/0, and then we gotta do IPv6, EIGRP 600. Now those are turned on. We didn't form any neighbors yet for some reason. For some reason, we did not form any neighbors. Let's go back to router 1 and see what the problem is. We did EIGRP 600, right? Yep. That's exactly what we wanted. Enable on the interfaces that's connected, and we did that. Do we have a router ID? That's the question. Let's look at router 2 and see. That's probably why. And I think that's what they get at with this. I can't remember because I did do this before. Normally, I just, wait to do this live, but I felt like recording, going over it first before I do that. Show IP protocols. There it is right there. See, no usable router ID found. So that's probably why we did not form a relationship, a neighborship yet. Router 2, display information about the running IPv6 protocols, which we just did. Did router 2 generate router ID for the routing process? No, it did not, as you can see. If so, what did it use as its router ID? It did not, so that's the answer to that question. Manually configure the router ID on router 1 to this, and on Eigrp version 6, router ID to, we're going to do router 1 router ID to this, and router 2's router ID to that. So let's go back to router 1, this guy right here. Change his router ID. We're going to change that to this 1001, right? And notice this is going to be lower than the other router ID, so we may have to clear the router ID process. Let's see. So configure terminal. We're going to do IPv6 Eigrp IPv6 router Eigrp 600, and we're going to do router ID, and he said 1.0.0.1. Oh, that's why we don't have to clear the process, because we're specifying, we're doing this specifically that as the router ID, so it's not going to select. We're saying this is your router ID. We're going to do the same thing, and on router 2 we're going to name that his router ID, but let's verify that we did that correctly here. Do show IPv6 protocols, and you can see that's the router ID, the new router ID now, right? It used to be this, and now we made it this. Okay. We're going to go to router 2, do the same thing, and make that his router ID. So we're going to go to IPv6, let me configure terminal, router Eigrp, I'm sorry, we need to do that over. IPv6, router Eigrp 600. We're going to say router ID is 1002, 1.0.0.2. Okay, that's that guy. To facilitate identification of routers of site 1, and notice now we have some neighbors. We got one neighbor right there. It popped up. To ensure the Eigrp routing process on each router can automatically create a router ID, assign the appropriate IPv6 address to the loopback 0 interface on each router. Refer to the IPv4 routing addresses table. So, we are going to change the, we need to fix these guys right here. We need to set these loopback addresses on the other routers, right? We're going to make sure that that's the loopback address, IP address for them. So we're going to go to router 1, exit. We're going to go to interface loopback 0 and make his IP address is 1001, 1.0.0.1, and then 255, right? That's what it says right there. Let's do a no shut, because normally this is a simulator. It didn't tell me. Normally, if you turn on a loopback address, it gives you a little syslog message, console message. Now we're going to do the router 2 and set that IP address. We're going to go to router 2. Yeah, that interface loop 0, and we're going to say the IP address is 1002, right? 1.0.0.2, 255.255.255.255. One thing I need to make note of is last time I didn't set these loopback addresses. Last time I did this, I didn't record it, and I just set the router ID, but I didn't actually create loopback addresses. So you can have the same ID. This is the same address as the router ID. So we're gonna go to router 3 and do the same thing. Router 3, enable, configure terminal, interface loop 0, and then we're gonna say the IP address is 1003, right? 1.0.0.3, 255.255.255, and we let's do a no shut anyway. Router 4, we do the same thing. This is router 4. Enable, configure terminal, interface loop 0, and then we are going to give him the IP address of 1.0.0.4, 255.255.255.255, and do the same thing on router 5 finally. I haven't been living up to this mantra, y'all. Lab every day. I have not. I'll admit that. We need to, especially now that they created these. Maybe this will give me a sense of urgency here. But these new exams coming out February 23rd. We need to get the cracking now. Configure terminal. We need to set the IP, the loopback address, interface loop 0. IP address is 1005, right? That's the address right there. 1.0.0.5, 255. Now, what was the last thing he said here? To facilitate that, we did that. Configure on the remaining routers on Site 1. Configure each router as a member of AS600 and enable Eigrp on all interfaces that connect to the routers within Site 1. So basically what we did with router 1 and router 2, we need to do the same thing with router 1, router 3, 4, 5. So we're going to go to router 3 right here. And we are going to basically turn on Eigrp version 6. Let's get out of this and go to IPv6 router Eigrp 600. And we are going to do he says here we need to enable it on a router. So now we're on router 3. We have 2. We need to do it on this interface and that interface from router 3, right? So this is router 3. Enable Eigrp for Eigrp version 6 on these remaining interfaces, that interface and that interface within Site 1. We don't have to do these guys because they're not in Site 1. So router 2 and router 4, right? So those are these two, FA01 and FA00. So we're going to go to interface FA01 and do IPv6, Eigrp 600, and interface FA. Notice we got a neighbor relationship right there, right here, as you can see. We've got an adjacency. FA00 is what it was. I can't remember. We did 01, and now we need to do 00. And do the same thing basically. IPv6, Eigrp 600 plus 0. I don't know if we created it. We're not going to get a neighborship just yet. So we need to go to router 4. Do the same thing. Get out of this, and we're going to say IPv6. Notice we're basically doing the same, commands here. Router Eigrp 600, and we're going to say it's becoming a little bit monotonous here, or tedious rather. We need to do the interfaces. So router 4, this interface and that interface, right, within Site 1. So which are router 3 and 5. So FA00 and 01, right? So interface FA00. We're going to say IPv6, router Eigrp, Eigrp 600. And then interface FA01. Notice we got a neighbor relationship. IPv6, Eigrp 600. I believe we're going to get a neighbor relationship there as well. No, we're not. We need to go to router 5 and do that. So we need to go router 5 and do that. Same thing we just did. Right, so we're going to do IPv6, router Eigrp 600, and we are going to say we need to go to interfaces. What interfaces are those? I believe it's the same thing, 0, 0, and 0, 1, right? Yeah, 0, 0, 0, 1, right? So we need a relationship. We need to turn on Eigrp version 6 for this interface and that interface. Those two interfaces, right? 0, 0, 0, 0, and 0, 1. Interface FA00. Let's say IPv6, Eigrp 600. 600. And then the labor, so we have a neighbor relationship there, 0/1, and then we're going to say IPv6, Eigrp 600. Now we turned it on. Now we have another labor relationship. Okay, on router 5, display information about the running IPv6 protocol. So we're on router 5. We are on router 5, and show IP, not IP protocols, right? IPv6 protocols. And he says here, did router 5 automatically generate a router ID for the routing process? If so, what did it use? It used this. Why? Because that's the loopback address. Remember, it's the highest loopback address. That becomes a router ID. If that's not available, then it's going to pick the highest IPv4, or it's just going to pick the highest IP address that you have available. Verify. We're almost done here, y'all. In this task, you will verify, run verso commands, basically. Router 1. Let's go to router 1. Display the routing table. IPv6 routing table. use the output to show the following questions. How do we display the routing table? Do you know? Pop quiz. Show, not IP route, because that's going to show you the IPv4 routing table, right? That's the IPv4 routing table. We need to do show IPv6 routes. And that's our IPv routing table right here. Make this a little wider for y'all. Okay. That's our IPv6 routing table right here. How many networks has router 1 learned about from its neighbors? This is connected, right? See, so that's directly connected. He didn't learn it. He already knew about that. So he learned about this network that's directly connected as well. He learned about these dynamically. This one, and that one. So router 1, he learned about 3 networks. Router 1 learned about 3 networks. I believe he learned about that network. Oops, I didn't mean to do that. Learn this network, that network, and this network dynamically. Those other 2 are directly connected. So he learned about this network, that one. Let me see. This network, that network, and this network. That one and that one is directly connected, right? 2 C's right there, a C and a C. So it's directly connected. He already knew about those. What is notable about the 2001 DB8 blah, 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 blah networks? Ends in 103. So this network, what's notable about this network right here? I believe it has 2 ways to get there, basically. I think he has a successor and a feasible successor, I believe. Or they're basically 2 successors. I don't remember. I don't know. Let's see. Task 2, question B. Task 2, question 1B says here, it's notable because there are 2 equal cost paths, just like we said in a round table. And no, I did do this this lab earlier, but I did not really look at this answer right here. So we got 2 equal cost paths. We can change this by doing the variance command, but we're not going to do that right now. All right, so let's race through this. We almost done, y'all. Router 1 display a list of primary and backup routes that's been learned from its neighbors. We do that with show IPv6 Eigrp topology, and I believe it's all links. That's going to show you the backup, the feasible successors and successors. You'll see 2 numbers in the parentheses, like this right here, and this right here, and this right here. The first number is the feasible distance, right? So full, feasible, full, which is the total metric or cost for this router to reach the destination network. The second number is the advertised distance, so AD. The router that's next to you, he's telling you how far it is from him, the destination, which is the advertised metric from the directly connected neighbor from which this route was learned. Use the output to answer the following questions. How many questions we got? We got 5. We got to do. We got to race through this, y'all. What is the advertised distance to the this network right here from router 1? Advertised distance is, remember, is the second number, so it ends in 102. It's this one right over. Y'all see it? This one right here. What's the advertised distance for that? This is the feasible distance, right? These are feasible. That is it right there. But notice we have 2 here. Which is which? What is the advertised distance? The second one is the advertised distance, right? Second one is the advertised distance. What is the feasible distance to the 192.168.1.48 network from router 1? That's an IPv4 address. This is a tricky question right here. I don't even know. Let's see, 2B. Let's answer. Let's look at that. Let's look at the answers for that. 2B. This might have been a typo. Feasible distance to that, he wants to know. So the feasible distance to the one that ends in 102 is 307.20, which is that one right there. So I don't know, maybe that'd have been maybe that's a typo. On router 3, display information about its neighbors. You know how to do that? So we're gonna go to router 3. Where's router 3? Right here. Information about its neighbors. Let's Control Z out of this. Show IPv6 Eigrp neighbors. That's it right there. How many neighbors does the router have? Looks like we got 1, 2. What address does the output display to identify each neighbor? Right here, link local address. Remember we said that in the slides here? Right here. Uses link neighbors link local address and next hop to IP address. Right? Last question right here. How does this differ from the way Eigrp identifies its neighbors? Well, EIGRP for version 4 identifies its neighbors using obviously an IPv4 address, but it uses their router ID, I believe. No, it might use the interface that is connected. I can't remember. Router 5, display information about EIGRP traffic, EIGRP version 6 traffic. From which router he said to do that with? Router 5. So let's go to router 5. And then show IPv6 EIGRP traffic is how to do that command right there. How many hello packets have been sent? Right there. Sent and received. That's easy. Sent 178. On router 4, let's go to router 4. Display information about the interfaces. How many pending routes are displayed? So we do the interfaces by doing show IPv6 EIGRP interfaces. There's 2 interfaces participating in EIGRP version 6. How many pending routes are available? Pending. Right there. 0, 0. And that's it. I think that's it for y'all. That is my contact information. That's my Twitter. That's my YouTube. Please comment on this video if you like it. Please like this video. Please share it on your social media. And subscribe. Hit that notification bell. We're going to be racing through these because I've been slacking on these videos lately. Like this video. Please comment, like, subscribe to the network.